Go ahead and get started on a help video for the grade 7 for the, in this case, lessons 3 through 5. We're going to go over the practice problems and talk about how to answer some of the questions. In this video, we're not going to give particular answers, but we are going to show methods and talk about how to approach the problems that are in the problem set. So we start here with lesson 3, and lesson 3 has 4 different sets of problems that you have to answer. The first of which is just asking you, and obviously on a printed version of this, you would be provided with enough space that you could draw these actual images on here. So you're presented with 3 shapes, and you have to scale these up based on a provided scale factor. Now the scale factor here, in this case, is 2. So that means that if the scale factor is 2, you need to make the shape that's given to you here, which is shape A, twice as large. So the quickest way to do that is if you're looking at this with on paper, your job here is to measure these sides. It's probably best and easiest to measure the vertical and horizontal sides and just increase them by a factor of 2. So I believe on paper, if you on a regular 8.5 by 11 paper, this particular side would print to 2 inches. So that means that you would scale it up by making it 4 inches. So every side that you measure, you would just make them twice the size. The same thing with B. In this case, though, you're using a scale factor of 1/2, and when you use a scale factor that's less than 1, you have to make the shape smaller. So that's the difference between scaling up and scaling down. A scale factor of 1/2 would actually take this shape and make it half the size. So once again, if you measure each of these sides, you're just going to go half of the distance. So if this was like, say, 5 centimeters, you would just go to 2.5 centimeters. With shape C, this is a little tougher because shape C involves a scale factor of 3/2. Well, this is still greater than 1, so you're going to have to make sure that when you increase the size here that you need to multiply it by either 3/2 or 1.5. So again, if you measured this and let's say this was, say, 3 inches. Well, 3 inches times 3.5, 3/2, excuse me, not 3.5. 3 inches times 3/2 is 4.5. And the reason, or how you would do that in your head, is you would start with what you're starting with 3 and then add half of that. So 3 plus half of 3, which is 1.5, that would be 4.5. So again, you would draw this, and since this is a parallelogram, really you just need to measure this side, and then you can kind of draw a parallel line over here, and get yourself a nice parallelogram. So, but case in point, you would want shape C to be larger by about 50%. Okay, for problem number 2, this question here basically deals with a perimeter problem. It's sort of a scale problem in disguise. Quadrilateral A has side lengths of 6, 9, 9, and 12, whereas quadrilateral B has a shortest side length of 2, and it is a scale copy of A. So your job is to figure out what the perimeter of quadrilateral B is. Well, if the shortest side in quadrilateral A is 6, and the shortest side in a scale copy of it is 2, then that means what are you going to do to divide the 2? Well, 6 divided by what gives you 2? So if you're thinking, well, 3, then that's almost like the scale factor. In reality, the scale factor is 1/3. You're ending up with a smaller, a smaller scale copy. But you need to know the other side lengths to go with that as well. So if you divide 6 by 3 to get 2, you would also divide 9 by 3 to get 3, 9 by 3 to get 3, and 12 by 3 to get 4. So the side lengths in quadrilateral B are 2, 3, 3, and 4. So the perimeter would just be the sum of those. So add those up, and that gets you your perimeter. Now for problem 3, I have another window open I'm going to switch to, which is here. And I have basically a scaled up version of this and kind of giving away the answer, but I'm going to talk to you how we get this particular shape in the first place. So this particular shape, as you'll learn as see here, is that we have a side length. Let me use my text tool for a second. We have a side length from A to B as 3, a side length from A to F as 2, a side length from E to F as 1, a side length from D to E also as 1, and a side length from D to C as 2, and a side length from B to C as 1. So if you add all of these up, 3 plus 2 is 5, plus 6, 6, 7, 9, 10. So the perimeter of this shape is equal to 10. Now, when we scale figures and we get a new perimeter, the perimeters would also vary by that same scale factor. So in the problem, let's go back to the problem real quick where it reads for us. It says that the polygon with a scale copy of the polygon with a perimeter of 30 units. So if I know that the perimeter is 10 and I need to get to a perimeter of 30, how many times bigger does this shape need to be? Well, 10 times what gives you 30? In this case, it's 3. So I had to make a scale copy of this that was 3 times as big. So you'll notice that every side length that's here is 3 times the size. So in this case, this is 9, this is 6, this is 3, this is 3, and this is 6, and this is 3. So you'll notice again, if you add all of these up, this should add up to 30. So let's see if it does. 9 and 5 is 14, 17, 20, 26, 29. Oh, what did I miss one? I missed one somewhere. What did I do? Oh, this is not 5. Silly me. This is 6. Sorry about that. That's 6. So that takes care of that problem. And that takes care of that. Okay, so I had just miscounted. That was 6. If you caught that right away, good for you. Okay, so that's going to be 30. So that takes care of that problem. Takes care of the scale copy, added in with the fact that we are perimeter of 30. Now, for this problem here, this one's a simple recognition problem. Priya and Tyler are discussing figures. Priya thinks that B, C, and D are scaled copies of A. B and D are scaled copies of A. Do you agree with Priya or do you agree with Tyler? Thinks B, C, and D are scaled copies of A. Well, if you look at A and you look at B and C, do these appear to be the same as A? Does D appear to be the same as A? And what you would be looking for here is, are all of the side lengths the same or increased by the same factor? So if you look at B and you say, do all the side lengths increase by the same scale factor? You would say, no, it does not. So you can eliminate that B as a possible scale factor. So Tyler and Priya both have some misconceptions that you need to address in your answer. Okay, so let's move on to the next problem set. And on this problem set now, we are talking about the relationships between scale copies. So a couple of points that I want to remind you from previous video that I've sent, also lessons that we've talked about in class, is that between two scale copies, the angles between the two shapes are the same, but the side lengths are what can change, and they would change by the same scale factor. So if you look at problem 1, and you're supposed to analyze whether all or some or what statements of these are actually true or false. So I'm going to identify 2 of these statements for you, and so I can get you in the right avenue of your thinking. All statements that must be true for any scaled copy Q of polygon P. Do the side lengths have to be all whole numbers? Well, the answer to that is no. Why would all of the side lengths have to be whole numbers? You can scale up by any number you really want. Even if you scale up by 1.1, that's going to cause a lot of your side lengths to become decimals if they were whole numbers. So of course, they don't have to be that case, right? Does Q, any scale copy, does, I'm looking at C. I'll do 3, that's fine. Does Q have to be a right angle? Well, Q has exactly 1 right angle. Well, the answer to this case is actually this is yes, this is true. Because again, based on the fact that the original shape has a right angle, that means that any scale copy of this shape will also have that same right angle. Similarly, for statement B, where it says all of the angle measures are whole numbers, if you look at this shape, all of the angle measures currently are whole numbers. These angles will not change in any scale copy of this figure. So therefore, all of the angles will remain as whole numbers. Okay? The other statements, that's kind of what you have to think about. If you remember that the main points between 2 scaled copies is that all of the angles are the same between any copy of it, and all of the side lengths are proportional to some scale factor, that will help you answer the other 3 statements in this question. Now let's scroll down and look at number 2. We have quadrilateral PQRS being a scaled copy of quadrilateral ABCD. Point P would correspond to A, Q to B, R to C, and S to D. So there's your corresponding points. And just so you know, the name of a polygon like this and the name of a polygon like this, where those points are in the polygon names correspond to the corresponding points. So A would correspond to P because that's the first letter in the name, and S would correspond to D because those are the last letters in the name. Now, if the distance from P to R is 3 units, what is the distance from Q to S? Well, P to R corresponds to B to D. Sorry, A to C, because it's based on this name, right? P to R. A to C. So if I look over here and I see A to C, what's the distance across if P to R is 3 units? Well, from A to C, if I look at my grid, 1, 2, 3, 4, 5, 6 units across. So what's the difference in factor between P to R and A to C? Well, if you answered A to C is twice as big, then you're on the right track to getting the correct answer to this question. Because in order to determine where Q to S is, you have to know something about B to D. That should be able to help you answer what the answer to this question is. Okay? Because the distance from B to D would also vary by the same scale factor as with P to R and A to C. Now, next problem. We have a figure here, scale copy of figure 1. Figure 2 is a scale copy of figure 1. Okay. Number 1 says identify the points in figure 2 that correspond to the points A and C in figure 1. Label them P and R, and what is that distance? So all you need to do here is A and C is here. P and R would be here. How far apart are those points? Okay. Then it says here, identify the points in figure 1 that correspond to Q and S. Label them B and D. These are over here. What's the distance between those points? Again, count it. What's the scale factor? Use those distances you had mentioned in 1 and 2 to answer that question. And then if it says here G and H are 2 points on figure 1, but they're not shown. The distance between G and H is 1. What is the distance between those same corresponding points in figure 2? For this, I suggest you just put G and H on here and kind of recognize that if the scale factor you said in 3 is correct, you should be able to answer that question with number 4, because if you put them here, they would be here, and they would obviously be further apart because they're on a larger version of that. All right, and last question here. To make a batch of lavender paint, the ratio of cups to pink paint cups is 6 to 5. What are 2 more ratios of pink to blue that are equivalent to this ratio? This is basically like fractions. If you just multiply these numbers by the same number each time, you'll get yourself equivalent ratios for it. Okay, that's not too bad. All right, one more problem set. Now we're talking about scale factor size. Okay? In problem 1, your job is to figure out whether they are greater than 1, less than 1, or equal to 1 between 2 different combinations of these 4 shapes. So I will remind you, if you listen, of course, here, to what is the determination between what the, whether it's a greater than 1, less than 1, or equal to 1. If the copy is larger than the original, then the scale factor is greater than 1. If the copy is smaller than the original, then the scale factor is less than 1. But if the copy and the original are the same size, then it is equal to 1. So if I look at number 3, if from Q to S means Q is my original and S is my copy, Q being larger than S means that the scale factor is less than 1, because we're starting here, going to here. Scale factor is less than 1. And the rest of these questions would be answered similarly. Either it's less than 1, equal to 1, or greater than 1. For problem 2, triangle S and triangle L are scaled copies of one another. What is the scale factor from S to L? Again, pick a side. I recommend this horizontal side, and see what the difference is between those distances and divide those 2 numbers. So the scale factor from S to L would be a division of what numbers to what number. So L, the size on L, to divide to the size on S. For number 2 would be the other way around. Okay, so the 2 numbers you get here, 1 and 2, should be reciprocals of each other. Triangle M is also a scale copy of S, but the scale factor from S to M is 3 over 2. What is the scale factor from S? So I'm going to suggest that for here, you look at your answers to 1 and 2 to kind of clue you in as to what the answer to this question is. Hopefully you'll see the pattern. Number 3, are 2 squares with same side lengths scaled copies of one another, and why? Well, to answer this question, you're going to have to think about what the property of a square is. Okay? If you have a square on one side that's got side lengths of 5, and another square that's got side lengths also of 5, are they scale copies of each other? Do all of the corresponding sides have the same scale factor relationship between the 2 of them? And of course, do they have the same angles between them? Okay, so I'll let you kind of surmise the answer to that question. For number 4, quadrilateral A has side lengths 2, 3, 5, and 6, and B has side lengths 4, 5, 8, and 10. Could one be a scale copy of the other? Again, what is the mathematical relationship at work? All right, so again, with regards to problem number 4, your job is to figure out, is there a mathematical scale factor that is equivalent from 2, 3, 5 to 6 to 4, 5, 8, and 10? If there is, then they could be scale copies of each other. So either they are or they're not. And the last problem here, any ratio that's equivalent to 12 to 3. So if you think of this as a simplified fraction, what's a number you can knock out of 12 and 3? Well, both of these numbers could be divided by 3, so that means that the base ratio here is 4 to 1. So if it's 4 to 1, any of the ratios that would follow that 4 to 1 equivalence would be an answer to this. And obviously you see one of the answers is indeed 4 to 1, so you know C is one of those ratios. Okay? So I will let you decide the other equivalent ratios on here. And as always, if you have further questions, you can leave them in comments below, or you can send your teacher, me, an email if you are in my class. I hope you have a wonderful rest of your day, and don't forget to be awesome.